So here is problem 17 of the second graded homework. And you're given that we have an aqueous solution. That means that's water where we dissolve something into that water. And normally water boils at 100 degrees. Now that we dissolve something into this, it's boiling at 103 degrees. So this is a colligative property change that's occurred because we dissolved something in there. That's boiling. It wants to know what the freezing point of the solution is going to be. And it gives us the constants for both boiling and freezing. So I'm going to move to the worksheet. So I've now transferred over here for these colligative properties, boiling point elevation, freezing point depression. The change in the temperature is equal to a constant that's specific to that solvent times the molality of whatever we dissolve in that solvent. Normally, water boils at 100 degrees. It's now boiling at 103 degrees, so the delta T is 3 degrees C. 3 degrees C is equal to the constant, which is 0.51 degrees C per molal, times the molality. And what we don't know here is the molality. So we're going to solve the molality of the solution, and then we're going to plug in the value for freezing, and we're going to calculate what the freezing point will be. So in this case, all we need to do here is take 3 degrees C. We're going to divide both these sides by 0.51. So 0.51 degrees C per molal. C cancel. And we're left with, in this case, that turns out to be 5.9. So 5.9 molal. That's the molality of the solution. Now we can plug that in for the freezing point, because the question asks what is the freezing point. So we're going to say, well, the delta T now for freezing is going to be the freezing point constant, which is 1.86 degrees C per molal, times now we know the molality is 5.9 molal. That cancels, and our delta T, basically 11 degrees, right? Or it drops by 11 degrees, and that is problem number. So here in problem 18 now, determine the vapor pressure of a solution that contains 76.6 grams of glucose in 250 milliliters of water. So we've got pure water. We're dissolving solute into that to make a solution, and that will reduce the vapor pressure. And the way this turns out, this is Raoult's law, however you want to pronounce that. It's going to be the mole fraction now of the water times the pure vapor pressure is now the new reduced pressure. So let's do that calculation. So in this case, what we want to do is calculate the vapor pressure of the solution, and that's going to be the mole fraction of water. So the amount that is still available at the surface is determined by the mole fraction of that water times the pure vapor pressure. And the mole fraction is going to be, we calculate how many moles of H2O we have over the total number of moles in that solution. And so you're going to have to convert glucose into the number of moles. You're going to have to convert the water. So we have 250 milliliters of water. That means 250 grams of water because the density is 1. That, convert those number of grams into moles. You've got the total number of moles. And then the mole fraction times that pure vapor pressure gives us the new vapor pressure. And that is problem 8. Now this next problem, number 19, is not that much different. Now we have a KCl solution. So it's an electrolyte that we dissolved in water. And it tells us we have 25 grams of that electrolyte, KCl. We calculate how many moles we have of that. And then we remember that KCl is an ionic compound. It's a salt. And that means for every mole of potassium chloride, KCl, we have a mole of K plus and a mole of Cl minus. So whatever number of moles of KCl we have twice as many moles of ions. And then we still calculate what the mole fraction is. So the mole fraction of water, again, moles of water over the total moles, but now we have to add moles of the water plus the moles of the ions, not just KCl, the moles of the ions, times the pure vapor pressure will tell us the new vapor pressure. And that's it for problem 19.